Chemical Kinetics Part 8, Integrated Rate Laws for First-Order Reactions. Once again, this is a sheet with all of the important equations that you would use for calculations involving chemical kinetics. In this video, we're going to take a look at how you can take the differential rate law for a first-order reaction and integrate it to get the integrated rate law for a first-order reaction. You don't have to use calculus to do chemical kinetics. The purpose of this video is really just to show where the integrated rate law equation comes from. So for a first-order reaction, where we have a single reactant A forming products, we can say that the rate of the reaction is equal to the rate constant K times the concentration of A. Now the rate of a reaction is always equal to the negative slope, or the negative derivative, of concentration over time. So we're going to take these two expressions of rate and make them equal. Let's rearrange these two expressions so that we get so we can separate the variables. So we have d concentration of A divided by concentration of A is equal to negative K dt. We're going to integrate both sides from a lower limit of 0 to an upper limit of t. On the left-hand side, we can factor out the inverse of the concentration of A. So we get an integral from 0 to t of the inverse of concentration of A, d concentration of A. And on the right-hand side, we can factor out the negative k. So we get negative k integral from 0 to t dt. On the left-hand side, when you solve this integral using the rules of calculus, you get natural log of concentration of A at time t minus natural log of concentration of A at time 0. On the right-hand side, the negative k is already factored out, and the integral from 0 to t dt is equal to t minus 0. So we end up with negative kt minus 0, or just negative kt on the right-hand side of that equal sign. We can rearrange this expression so that we get natural log of concentration of A at time t is equal to negative kt plus natural log of A at time 0. Now this is a slope-intercept form of an equation where the y-axis value is the natural log of concentration of A at time t. The x-axis value is t, time. The slope m is negative k, and the y-intercept b is equal to the natural log of A at time 0. So if we graph out natural log of concentration of A at time t versus time, we're going to get a straight line, because again, that's a straight line equation there. That's a slope-intercept form for a straight line. The slope on that line is going to be negative k, and the y-intercept is going to be the natural log of A at time 0, or the natural log of the initial concentration. The concentration at time 0 is the initial concentration. So once again, with integrated rate laws, we see that they relate concentration to time.